Assalamualaikum, my name is Falahi Binti Shahril. Today I am going to present my thesis, which is evaluation of antibacterial and anti-inflammatory activity of Senna alata and its phytochemical constituent.
Introduction. Background of study.
Senna alata, locally known as kelengkang, is not commonly used as a traditional herb in Malaysia. According to Oladaji in 2021, there are around 250 to 300 species of Senna alata that are distributed and cultivated across the world. This herb is under the family of Fabaceae, and it is a type of shrub that can grow up to 3 to 4 meter high. The flowers are a bright golden color and has an unpleasant smell, while the fruits exhibit brown color when they fully matured. Senna alata, also known as Cassia alata, is widely distributed in tropical and subtropical regions of the world. Fatmawati in 2020 stated that several parts of these herbs were reported to show several therapeutic potential such as antibacterial, anti-inflammatory, and antifungal activities.
Problem statement.
First, Senna alata show very high value and usage in the herbs world. Unfortunately, in Malaysia, it is not widely used. Second, some people are allergic to antibacterial cream when they are applied it to the skin, and conventional anti-inflammatory treatment show several side effects. Next, in the agriculture field, various chemicals are used to increase crop productivity and treat plant diseases. The excessive usage of the chemical not only threatens the environment but also affects public health.
Significance of study.
Senna alata show a high market value in other countries. Second, the study also will provide new insight into the medicinal benefit of Senna alata. And third, Senna alata from Malaysia with anti-inflammatory properties have not been documented in a single review paper.
Objective.
First, to evaluate antibacterial activity of Senna alata extract against selected bacterial species using this diffusion method. Second, to determine the anti-inflammatory activity of Senna alata leaf extract using inhibition of A-albumin method. Third, to identify the phytochemical constituent of Senna alata using qualitative phytochemical tests.
Research question.
First, how to evaluate the antibacterial activity of Senna alata. Second, how to determine the anti-inflammatory activity of Senna alata leaf extract. Third, what are the bioactive compounds in Senna alata leaf? 4. How to identify phytochemical constituent of Senna alata. And fifth, how could different percentage of solvent influence in antibacterial and anti-inflammatory activities?
Literature review.
This table shows the summary of antibacterial activity reported from Senna alata plant. Senna alata plant is known to have biological activity such as antibacterial properties. Thus, from literature searches, there are enough evidence that Senna alata exhibit antibacterial potency. According to Zhang in 2018, extraction has been acknowledged as a critical approach for collecting and extracting bioactive chemicals from a sample in several studies. The effect of various solvent on the phytochemical content of plant parts produces a variety of results of finding antibacterial properties. The main gap in the previous study is the researcher more focusing on the antibacterial effects against ethanol and methanol extraction. Hence, the study focused on the difference percentage, which is 70 and 95% of ethanol of same solvent extraction. In addition, since the literature published has been reported mostly not from Malaysia, hence the study will also focus on the local growth of Senna alata in Malaysia. This table explains the summary of inflammatory activities reported from Senna alata plant. Thus, from the literature searches, the carrageenan-induced red pore edema is widely used to determine the anti-inflammatory activity, and it has been fully characterized in the past. According to Posadas in 2004, there are about 400 reports where red pore edema has been used. However, there are less A-albumin tests had been done to test the anti-inflammation. Hence, the study will focus on the A-albumin test to determine the anti-inflammatory effect of Senna alata.
Methodology.
The leaf was obtained from Naga Lilit Kedah, Malaysia. The fresh leaf of Senna alata were washed with water followed by oven drying at 50 degrees Celsius for 12 hours. Then the leaf were ground using an electric blender. Then the powder was sieved using a strainer, then to transfer into a clean airtight container. Next, to prepare the plant extract, a weighing balance was used to weigh 30 grams of leaf powder. Then powder was soaked in 200 ml of every different concentration of ethanol. To get crude extract, the solvent residue was further evaporated using a rotary evaporator at 45 degrees Celsius and 65 rpm. Then the solvent was transferred to a beaker and heat on a hot plate until remaining solvent evaporates. The plant extract were prepared at a concentration of 0.5% each. The disk diffusion method was used to assess the antimicrobial activity of Senna alata leaf extract. The sterile Muller-Hinton agar was used to incubate the two strains of bacteria. Then, the sterile paper discs were immersed with 10% of 220 and two different groups of solvent, which is 95% of ethanol and 70% of ethanol, with in three different concentrations of the extract, 0.5, 0.25, and 0.125% for antibacterial examination. Ampicillin was used as a positive control, while 10% of 220 was used as a negative control. Methodology is for anti-inflammatory egg albumin inhibition test. The egg was reconstituted in a 5% V over V aqueous solution with isosaline to be used as an albumin source. 1 mg of Senna alata leaf extract was dissolved with 10 ml ethanol to produce the sample solution. 10 mg diclofenac sodium was mixed with 4 ml ethanol to form the standard solution. In several test tubes, egg albumin phosphate buffer with a pH 6.4 and different percentage of the test extract was used to make the test solution. The standard solution was made in the same way, except rather than with the extract, diclofenac sodium was used. As a control, the same volume of distilled water was applied.
The qualitative analysis of phytochemical compound was carried out to observe the presence of different phytochemicals in Senna alata leaf extract. The test was flavonoid test, tannin test, alkaloid test, saponin test, and terpenoid test. Result and discussion.
The result in table revealed that the disk diffusion method evaluates the antibacterial activity of Senna alata extract. Senna alata leaf extract by 95% ethanol at 0.5% showed the highest effects against E. coli. 70% ethanol at 0.125 showed the diameter that appeared to have highest zone of inhibition. However, there are formations of fuzzy zone within this diameter. This might be colonies of resistant bacteria or bacterial regrowth following decomposition of the antimicrobial agent. In addition, from the result gained, Senna alata leaf extract with 70% of ethanol worked better on the test organism compared when extract with 95% of ethanol. This is because the presence of water is essential in the inhibition of pathogen with denatured ethanol. Water functions as a catalyst and is essential in the denaturation of protein in vegetative cell membranes. According to Salvage in 2014, 70 denatured alcohol penetrate the cell wall, more truly permeating the entire cell, coagulating all the protein and therefore killing the pathogen. Besides, increased water content decreases evaporation, hence improving surface contact duration and efficacy. As a result, a protective layer is formed which shields other protein from further coagulation. Explain the anti-inflammatory effects of Senna alata. The decreased absorbance in the extract and the standard drug with the respect of control indicate the protein stabilizing activity with the increased dose. In addition, there is a decreasing trend of inhibition rate was observed with 70% ethanol leaf extract. This may be due to the solvent partitioning effects. The result of this study showed that different solvents had significant effects on the extractable solid yield of Senna alata. This finding was supported by previous study, which also found that different extraction solvents significantly affected the extraction yield of sample. Hence, this might be the reason why 70% ethanol leaf extract show decreasing trend of inhibition. Tests show positive result where flavonoid there is changes from intense yellow color to colorless yellow, while the presence of tannin can be determined by the appearance of the green-black color. In addition, phytochemical screening indicate the presence of alkaloid by Mayer test, where there was a formation of an organic precipitate. Next, the presence of saponin was determined when there was a formation of stable form. Lastly, phytochemical screening indicate the presence of terpenoid by the appearance of ring when the extract was mixed with chloroform and sulfuric acid.
Conclusion and recommendation.
In the present study, results indicate that Senna alata included in intermediate type of plant. Besides, the 95% ethanol and 70% ethanol extract of Senna alata show antibacterial and anti-inflammatory properties. Hence, selection of solvent percentage is important to ensure good amount of bioactive compound being extracted. This activity may be due to the abundant presence of polyphenolic substance including alkaloid, flavonoid, tannin, steroid, and phenol. The component of the extract prevented the heat-induced denaturation of albumin. Each bioactive chemical must be purified, and the purified form of the compound may exhibit greater activity when employed. Further study is needed on this plant extract to find the exact mechanism of action for its pharmacological properties over antibacterial and anti-inflammatory effects. In fact, the compound that might be responsible for the anti-inflammatory and antibacterial activity can be further elucidated through advanced chemical analysis using HPLC or GCMS. Besides, Senna alata have not been studied in terms of their biological properties. As a result, all other elements of the plant such as flower, barks, stem should be explored further.